Hello, in this video we're going to cover scope in the Swift programming language. So scope is essentially where a variable can be used. So an example would be in this function, print bottle count. We're going to create a variable bottle count is equal to 99 and we're going to print it. So when this is called, we will assume to get print 99. And then bottle count is equal to 99, so we will assume that it would print 99 twice. But here we're getting an error. It says we cannot find ball count in scope. And that's because this ball count variable, you could think of it as only active in this range. That's the scope. It's a local variable. But if we initialize var a bottle count outside, set that to 100, now it's a global scope. So now it will be 100. So we'll get 99 from this inside local scope, and we'll also get 100 from the ball count global scope since it's outside a function. And since this is inside these curly brackets, this ball count is only accessible here. That's the basics of scope. Now let's dive into more advanced examples. So in this example, we're going to describe why the code doesn't generate a compiler error if you uncomment line 10, why it does it generate a compiler error. And we get an error. And the reason is because foo again is inside this for loop this time. So we can say foo, we'll say the constant foo is in a for loop. So it has a local scope. That means it cannot be accessed outside the for loop. But in this case, when we uncomment it, it still works. So let's explain why it works. So the reason it works is because x, say variable x, the variable x is defined outside the for loop, so it has a global scope, so it can be accessed. It can be accessed outside the for loop. But same explanation here. But the concept foo is in a for loop is say define a for loop in a for, so it has a local scope, and that means it cannot be accessed outside the for loop. Now we have a function called greeting below. Use the variable shadowing when unwrapping greeting. If greeting is successfully unwrapped, print a statement that uses the given greeting to greet the given name. So if it's successfully unwrapped to have the value hi there, and then the name is Sarah, then we print hi there, Sarah. Otherwise, use hello to print a statement greeting and greeting the given name. Call the function twice, once passing the value for greeting and once pass in init. So let's call it. So we're going to use a variable shadowing. So variable shadowing essentially is using the same thing. So let's use the guard. So variable shadowing is when we say greeting is equal to greeting. So there are two variables, and the thing with a guard though is that variable greeting has a scope outside the guard statement too. So it'll be else. So if greeting is not null, Then we'll do the rest. If greeting is null, then we need to return a for printing. So we're going to print a, okay, let's actually assign it. We're going to print hello and then the name. And if there is a greeting, then we can just print the actual greeting plus the name. And let's see, we forgot a closing parenthesis here. And also, so the guard doesn't have a return or exit to scope. So let's do a return here. Now let's call the function twice. So let's do greeting, and let's say, it's a good morning. And name it John. Let's do a similar thing, but now in addition to this, to actually make this have a comma, so we'll have escape sequence, the greeting, comma, and then another escape sequence. So good morning, John, and here we'll just do a nil. So we're passing in a nil. So basically this should happen. Hello, John. Great. Now we're going to create a class called car. Classes are always capital. And it should have the properties for make model. So let's do var make. I type string, string, and int. So string var model is also type string, and then var year is of type int. Since this is a class, you'll need to write your own member-wise initializer. Use shadowing when naming parameters in your initializer. Basically, when we initialize it, we have to use shadowing to use the same names. So we'll do make, and it will take in a string, and we'll do model, and we'll do the year, which is an int. It'll make more sense when we actually do it, but now to initialize it, we're going to use self.make is equal to make. So, or what we're doing here is the make here and the make here is the same name. So this is calling this make, and this is calling the self. And the reason we're using shadowing is so we can demonstrate the use of self. And self basically says that we're going to access our car's properties. Also, the same thing for the rest. So model is equal to model self dot year is equal to year. Now let's make sure everything is accurate. Okay. Let's continue. So now we have a user struct and 3 user instances. These will be used throughout the exercise, and we're going to simulate a competition in the fitness tracking app. Okay. The function below takes an array of user objects and returns the user object that has taken the most steps. The body of the function first declares a variable that is an optional user, then loops through all the users in the array. Inside each iteration of the loop, it will check if the top competitor has a value or not by unwrapping it. And if the top competitor doesn't have a value, then the current user in the iteration is assumed to have the highest score and is assigned to the top competitor. If the top competitor has a value, there is code to check whether the current user in this iteration has taken more steps, then that is assigned to the top competitor. Okay. At that point, the goal is to assign the user with the highest score to the top competitor. However, the code generates a compiler error due to improper variable shadowing. Top competitor has a narrower scope than it should if it's going to be reassigned. Fix the compiler error below and call getWinner, that's the name of our function, passing in the array of competitors. Print the name property and the return user object. So let's fix the compiler error first. So here we're seeing that top competitor is a let constant. So what's basically happening is that we're assigning this top competitor to basically this, but we want to access this most likely. So what happens if we do self.top competitor? So we can't use top self because it's not struct. What we can do is change the name. So we'll say, rather than the top competitor, we could say top or higher competitor. And we'll just do higher competitor here. So now it knows, okay, so we don't need to change it. We'll just do top here because it wants to access that. We'll change this to higher competitor. This should fix the issue because now this isn't referencing this anymore. It's actually referencing that. Now let's call getWinners. GetWinners, and we're going to pass in a array of competitors. So I would assume the competitors array. Great. Now we're going to print the name property of the return user. So let's just say var top is equal to that. Okay, and then we're going to print top.name. Know that you fixed the function properly if the return name is active sitter. Okay, so it must be unwrapped, so what we can do is use if let. So if let that, then we'll add some parentheses. Okay, so we have to remove this var. Right, we have been returned active sitter. Write a memberwise initializer out inside the user struct above that uses variable shadowing for naming the parameters of the initializer. So let's create a memberized initializer. And we'll use variable shadowing, so we're going to need to use self. So we will do init, and this will be the first thing it takes in. This will be the second thing it takes in. Now we'll just use self name is equal to name, and we'll do self steps today is equal to steps today. Perfect. Now we can so above and use variable shadowing, so we have done that. Now write a failable initializer inside user struct above that takes parameters name and steps today as optional string and int. The initializer should return nil if either parameters are nil. Use variable shadowing when unwrapping the two parameters. So to do that, we will okay, so we have an error here, and I think we have to add the s here that we may have misspelled. Great. Now let's create a failable initializer. So init, and then it will be the same thing, but one major difference, which is the removal of, the addition of a optional in our input parameters. String and int are optional. So it should return nil if either are nil. So are we using it's like we're just going to use optional binding. So if let Let's use guard. Guard. Let's say name is equal to name, and steps today is equal to steps today. And we're going to return nil if either of those are nil. Oh, and yes, we have to set them equal to each other here. And if they're not, then we just okay, so then we're gonna now just set self.name equal to name, and self.steps today is equal to steps today. Oh, and we forgot our else here. Let's see if it fixes an issue. Oh yes, and the let here, since we're assigning two different, we're checking if these two different variables are optional or not. Okay, great. So we have fixed all the errors and we have completed this exercise. See you in our next exercise that will be dealing with enumeration. Bye.